everybody, Sergey.
Thank you. Welcome, everybody. The first question that I usually have by working with Intel when I meet someone, are you guys really doing software? Are you kidding me? Yes, we do. And actually, I'm 15 years doing numerical software at Intel. And Intel is quite good in doing this software. At least according to this EDC developer surveys, this libraries that we do is among the most popular on the market. And why we are doing software? Intel is certainly a hardware company, but by the time we launch the hardware, we want to make sure that the ecosystem is ready for that hardware. And we are working with the ecosystem in multiple ways. We work with big partners like Microsoft, Google, and many, many others to directly work on their software to optimize for latest hardware. But we also want our software, our hardware to run based on a wide range of software applications. For that, we do software development tools so other independent software vendors can use and accelerate their software for Intel processors. So Math Kernel library and integrated performance primitives. These are two examples how we deliver AI-optimized building blocks to the market. So market can reuse these building blocks and run faster on Intel processors. So that's, in a nutshell, in reality, it's really difficult to explain people how big is the ecosystem of our libraries and our tools. And I had a daughter, she was 4 years old, and this is typical age when kids start asking questions, what are you doing at your work, Papa? And I really had times to explain that I'm doing math. Kids really need to touch something physical when you do, and math is so abstracted. So fortunately, Intel had nice partnership with DreamWorks Animations in 2006, 7, 8, and we worked together with them to optimize their software so they can create brand new effects, really cool effects, in particular for this movie, Puss in Boots. So when I was in theater with my daughter, she was so impressed by that movie. So when the movie is over, lights were on and people heading to exit. My daughter still sitting in a chair, and she was looking at titles, and there was Intel logo on the title, and she was amazed. Papa, I now know what you're doing at Intel. You're making cats. That was very easy way for me to explain now how our libraries are used. They're really used broadly for a variety of purposes. And because of that, our libraries and tools are also part of these student education courses. At least in Russia, all major universities who are teaching programming, who are teaching parallel programming, they incorporate Intel tools in their programming courses, so students are really become aware how to get the best performance on Intel processors by programming multi-cores, by programming for clusters, etc. Okay. To give you a flavor what exactly this software look like, Math Kernel library, this is kind of library for high-performance computing, for really compute-intensive applications. It runs almost all IA-based top 500 systems. It's optimized for this whole range of Xeon Phi and Core processor families. It's C and Fortran APIs. It provides support for different OSs. Unlike MKL, the IPP library, it's targeting slightly different segments of applications. It's signal, image processing, computer vision, and it contains these building blocks optimized for highest efficiency. Unlike MKL, which is heavy load workloads, this library deals with tiny stuff, so it's really optimized, highly tuned in assembly, and we make sure that overheads, calling overheads to these functions are really small. So on the left-hand side, you can see this is really linear algebra, FFTs, random number generators, statistics, vector math, partial differentiation equation solvers. Here, this is the primitives that you can use for image processing, computer vision, signal, filtering, data compression, etc. That's kind of libraries we deliver to the market. And I meant there's C and Fortran APIs for these libraries, but really it's been used by broad ecosystem of developers, not only C and Fortran developers. And how we do that, and our engineers make sure that we publish instructions how exactly to use these libraries within Java, within Python, or with .NET languages, with domain-specific languages like MATLAB or R, and other packages. So it's really has broad spread across domains and languages. Okay. I have some good news for this particular audience. Intel has free software program for many years, but this year we increased focus on free software tools available for researchers, for students, for teachers, for open source contributors. So we really have good news for you. You can visit software.intel.com, qualify for free software, and see what tools are available to you for your work for free. In particular, Intel still offers our best software for money. And the reason for that, many of our enterprise customers, they really value premier support. They really value the guaranteed quality of support. But we also have free options for a variety of audiences. Like if you're an academic researcher working on some project and you want to use any of our libraries, Math Kernel library, IPP, you want to use message parsing interface library or trading building blocks, you can get it for free. If you're a student or teacher, you are eligible for cluster edition of our Parallel Studio, which beyond these libraries, it also includes compilers, C, C++, Fortran compilers, and performance analyzers, and tools for running these things in clusters. Also for free. And again, if you're an open source contributor, you can get the Parallel Studio XC Professional for free for Linux, for your Linux work. That's one part of exciting news. The other part of exciting news, this is the first when Intel publicly announced availability of new product, which is called Intel DAAL, Data Analytics Acceleration Library, which is now in beta. I was among architects of that library. And this is my baby. That's why I'm really excited to be here and talk about this new product. So what it is, this is a C++ and Java Scala library for data analytics. You can imagine this is the building blocks for machine learning. This is MKL-like. The difference from MKL focuses on the compute side. This library focuses on entire data flow. If you're a big data guy, you really know that bottlenecks are everywhere, from data acquisition, data transformation, to data processing. So we make sure that we optimize all these data processing stages. And also, if you're Internet of Things guy, you imagine that the analytics is now run not only on your laptop or on your server. Analytics runs everywhere, on every device. So we make sure that our library is optimized for all kinds of devices, Intel-based devices. And it supports a variety of usage models. Like traditional analytics, this is batch analytics, offline analytics. But with big data, you really need to have capabilities for distributed processing of this data, or you want to process this data in blocks in real time when data becomes available. So this library supports all these kind of usage models, online, distributed, offline analytics. That's the important thing. This library is not tied to a particular platform. If you're a Hadoop guy, this is fine. This library will run in Hadoop environment. If you're a Spark guy, excellent. This library will work with Spark and do distributed computing on Spark. If you want to use this library with MPI, perfect. This library will work with MPI just because it is abstracted from communication layer. If you are doing complex IoT analytics, you have multiple devices, multiple protocols, and all they communicate with different protocols. You really need to have abstraction of these protocols. This library is perfect choice for you. Okay? In terms of speed-ups that we deliver, this library is based on these great libraries that I already present, MKL and IPP. They are on the market for many years. And they're greatly optimized. And by using these optimizations, we get 100x better performance if we run R, for example. Or if you are using Weka, you can imagine 35 or better performance on select workloads. This is kind of optimizations that we target. A little bit more on supported usage models. For data analysis, there are two major usage models. If you are a data scientist, you first start working in interactive environment. It can be R, it can be Python, MATLAB, Excel, whatever else. So we envision that DAAL can be really helpful in these environments. It can accelerate your analytics on this traditional desktop or laptop and where you run your interactive environments. And we know many customers who are stuck with their laptop. They cannot run big enough application on a laptop because of performance issues or because of memory limitations. This library really opens the door for extra opportunities on interactive modeling side. And the other problem is when your model is ready, you want to deploy this model in production. This library is also really key in accelerating your analytics in production. And production, I really mean, it's not only your data center, your lab with servers, it's really across all devices. If your data is being generated on one end and being consumed on the other end, you really want to optimize all this flow. This is where library in all these pieces will run. Okay? A little bit more. What kind of stages do we target? These are typical data processing stages, data analysis stages. You start with data acquisition. Then you do some data preprocessing. Like if it's really big data, you typically have data compressed. You want to decompress this data. Sometimes it is encrypted, decrypt this data. Then you do some basic filtering, normalization. If you have really highly dimensional data, you typically want to apply some factorization techniques or dimensionality reductions like PCA, like SVD. So you can use this library to do these transformations. And then you want to analyze the structure of the data. Before you apply a model, you need to understand how your data is organized. So this library provides a variety of techniques to understand your data, like running clustering algorithms, running summary statistics algorithms. This is what you probably want to do. And then you want to apply this data to train your model and validate your model. And then finally apply this model for decision making. So all these stages are covered by this library. And it's up to you as application developer, as a problem solver, to decide what part of analytics you want to run on your edge device, what part of analytics you want to run on a client device, and what part of analytics you run on the server. We have some good news for Python development community this year. As I'm finished with this DAAL project, I'm now moving to the new project. And my new project is to bring this exciting performance to Python development community. My new team is working on the new technology that accelerates Python. And what we do, we get a Python interpreter. We include some popular Python packages like NumPy, SciPy, Pandas, etc. And we integrate MKL and IPP with these libraries. So these libraries benefit from our great optimizations in this library. And we'll compile this with our great Intel compiler, package this, so it is really easy to install and out-of-the-box usage. The other good news for you is that we're working on prototyping the performance analyzer for Python code. You probably know that existing Python profilers, they're really high overhead and not very granular, functional level granularity or so. Intel has a great technology which is called vTune amplifier. It runs with your C, C++, Fortran, Java code. We're now applying the same technology so it can profile the Python codes. And this is really exciting. So we are now delivering this as technical preview package. It will be announced soon. If you want to try this new technology, send us email, scripting@intel.com, and we'll enroll you in evaluation. We really need your feedback on that. So just to give you some initial numbers, this is not a product. This is just the technology that we would like the community to evaluate and provide the feedback to us. Our initial acceleration, when we apply MKL for some linear algebra kernels, we see that you can get 6 times, 10 times, 15 times better performance than traditional Python NumPy package can deliver on multi-core systems. But even if you run a single core application, it will deliver you up to 6 times better performance. And all this is available for Windows and Linux now, later for macOS, and now it's both 2.7 and initially we deliver 3.5. For the profiler, so like I said, most of existing profilers like cprofile, they have function level profiling and also high intrusiveness. This technology is really based on technique which is allowing us to profile the line level with significantly lower overhead. And the overheads are 10, 50%, which is amazing compared to 2x, 5x, 10x overheads with existing Python technologies. You can profile the entire application without any code modifications. You just run your application within this Python profiler, and you get the profile ready. Or you can run the window of your application. If you know that from second 5 to second 10, this is your representative profile, then you can do that by using this technology. This is really nice GUI-based and well-known. If you are existing vTune amplifier user, you'll find it. You are ready to use it out of the box. Okay. These are our eating own dog food. We applied this profiler in our internal infrastructure, and we tuned Python-based scripts in a variety of projects already. Like one of our projects, this is web servers for Billbot. We were able to reduce the time of running this script from 90 to 28 seconds, almost more than 3x improvement. The other piece of our infrastructure runs Python scripts for QA reports generation. And that was amazing reduction from 300 seconds to less than 2 seconds. That was amazing result of using this profiler. And also the build system itself, there were some bottlenecks that we were able to identify with this profiling tool, and we were able to reduce the build time from 6 to 3 minutes in our teams. This is kind of things that we think it will be really valuable for Python community. That's why we ask you to participate in this technology preview. And if we see that feedback is really great, we'll probably continue doing more exciting things in Python and other scripting languages. That's all I have, and I probably have some time for questions. Yep.
These Intel tools for Python, disregarding the profiler, it's a library, is it a replacement for, is it a full runtime like C Python? What is it?
So the question, what is exactly in our Python distribution technology preview? Initially, we get CPython. We get some other Pythons like IPython, Cython. We pre-built it for Windows and Linux. And we also get popular packages, about 40 packages, including NumPy, SciPy, Pandas, Matplotlib, these kind of packages. Everything is compiled, tested. We make sure that it's good quality and easy install.
Okay, so it's a distribution.
It's kind of distribution, yeah. And you can install other packages with pip provided in our package. Yep. Yep.
How's the licensing work?
The licensing? This is technology preview, if we are talking about Python and Witten profiling. So the license will be evaluation license, evaluation software license. Yep. It will be free to download and test.
How about using those libraries and those distributions?
They are pre-built, so we're delivering binary package. They are part of this package. You don't need separate license for all these libraries.
So those packages, can they be plugged into a different distribution? The accelerated packages alone?
I'm not sure. I think that Continuum has some different technology. At least we did not test that. I'm not sure it will work. We make sure that it works with pip.
So it's a drop-in replacement and you get the performance boost for free. So
Yes, this is a nice feature. The libraries that are underneath, like MKL and IPP, what they do runtime CPU detection. And they look, I have such amount of memory, I have such a big cache size, I have this instruction set. In runtime, these libraries select the best code path to run based on this runtime information. So by running this Python package, it will link MKL underneath. And MKL itself will decide the best number of cores to use to get the maximum performance. Yep. And if you don't want to use all the cores, there are some techniques to tune how to, for fine-tuning of that information. Yep.
What kind of control does the program have?
I'm not sure that I hear you well.
So what kind of control does the developer have in tuning the parameters or is all the decision made by the library?
For Math Kernel library, how much, what kind of controls do these libraries have to tune the performance? I think that you have some controls. You can select the number of maximum number of threads. You can select whether you want exact numerical reproducibility of results. Like, this is common problem at runtime. When you run on one core or you run on 10 cores, you may have slightly different results because it will schedule it and floating point operations are executed differently. If you want to make sure that exactly the same results are from run to run, you have such a controls to tune this. And that's it. Okay. Any more questions?
Thank our speaker.
Great. Thank you.